And this is our last output. So our last output, when this ramp is set out at some ground height, so whatever the ground height is, it's right over here, I want to know the angle between these two faces, because if this angle is too sharp, maybe my wheelchair is going to bottom out, or maybe this thing might seem just too steep in that case, and then it's just harder for my wheelchair to get into my assist lift. So that could be a specification that we want to make sure that we check when we're building my assist lift design that I have here. So to do that, there are a couple different ways you can do that in 3DCS. The way that I've selected is called the line angle measure. What the line angle measure does is it checks the angle between two lines. So I have two line inputs here. Each line consists of 2 points. So I just have 2 points on each side.
2 points create a line.
Yep, 2 points create a line, as Gary said. And then the other thing that you're usually going to want for a line angle measure is a projection direction. So what that means is that these two vectors can vary in 3 directions, but as this image is saying, or as your drawing might be saying, I want those vectors projected onto this face, or this plane, into this view. And I want to know what this angle is here. So whatever that angle is, it comes out to like nominally be about 10.5 degrees, I think. That's the angle that I want checked. So if my ramp or my platform are deviating a lot towards us, it's not what I'm checking here. What I want to check is to see how much these two deviate relative to each other in this plane. So how I do this, and again, several different ways in 3DCS to do this. But how I do this is I don't have any form tolerance on either of these faces, so I'm not super concerned with form tolerance. So what I've done is that I have a feature point at the center of each face, and then I have a dynamic point just 30 millimeters off of those. And that point and that dynamic point is just representing my vector. That's the normal vector of those faces. That's all those inputs are doing. So that's how I do this. I think it works, gets the job done. So let's go to the ramp angle dialog. So if I nominal build, we'll see that our nominal value is about, like I said, about 10.5 degrees between those two, and I project it onto this face, this plane right here. And then if I select the deviate button, we can see that that number just changes ever so slightly to be a larger number or a smaller number, depending on what direction our vectors are varying in.
And so it's not showing it, but because this is a line angle measurement, that spec limit is plus or minus 1 degree?
Yes. Yeah, so your unit here would be in degrees. It's a good question, Gary.
And then if you wanted, as Spencer mentioned, he wants to know the angle in this view.
Mm-hmm.
So that's why he's got that type in vector. He can use the pull down and eliminate project on plane.
Yep.
And then it's the true angle.
So yeah, now it's the true angle, and that means it's just going to measure the angle between these two vectors in space, independent of plane. So that's the current now. It'll still be pretty similar because most of the variation is happening in that one plane we're viewing. But it will be different from a projection on plane option.
And this is where you can write this line angle measurement and then copy it, and you can check the line angle in X, Y, Z, change the vectors.
Yep.
So you can break it down quickly and easily, depending on what kind of information you want.
Real quick, if I wanted to check that in different positions, or I had would I use like a tolerance to do that, or would I do different?
Check the ramp in different positions. Yeah. So that's a good question. I actually have a move in my model that lowers my ramp down. So if I go ahead and I toggle active, there it is. Oops, not the help button. Then now I have that move turned off, and then now my ramp is hanging out in a, I don't know what's, okay, there we go. I think I triggered a Creo prompt, and that's what happened there. I had like Z, I think. So now you see that I have my ramp in the upward position, and if we go back in that ramp angle measure, first of all, I wanted to point out this actually starts off as associate direction by default. So it's projecting onto an associate direction, and that angle is virtually 0 every time. So I'm going to change this back to project on plane. Oops. Project on plane and then type in. And I think I want it to be in the Z direction, if I remember correctly. Yeah, so now it's measuring those two vectors projected onto that correct plane. And you can see that that number used to be about 10.5. Now it's 59, almost 60 degrees. So if you wanted to check multiple, like several different phases, so if you wanted to check this in its up position and its down position, you either have to use, I would recommend that you use multi-level modeling so that you have a different assembly level where you're doing that measure. So for example, I'd put that measure like maybe at this level rather than at this overall assembly level that I have down here, so that before my model gets to this lower ramp move, it's already measured this angle here, and then it lowers the ramp, and then I can take another ramp angle measure.
Would you utilize mechanical at all to give that a motion, like a kinematic motion, and then be able to check that throughout the?
Yeah, that would work as well.
Yeah, you could use classic moves for most of the building, and if you needed to check the ramp throughout its range of motion, you could simply put the ramp on with a revolute joint and apply a motion move to that. So you don't have to use mechanical moves for the entire assembly to be able to take advantage of that kinematic simulation function.
Mm-hmm.
Correct.